Okay, in question 2, we were asked to tell if the terms are like or unlike. So think of like, if things are alike, they have to be similar. So with the terms, they have to have the same exact variables attached to the coefficient, as well as the same exponents with the variables. So if we take a look at these two here, they both have x, and the exponent for the x, they both have a 1 there, essentially, and they both have y's. And the y's both have an exponent of a 1. So therefore they're alike. They both have xy's. Now, this one is just accidentally not written in alphabetical order, because typically we list our variables in alphabetical order, so it could be rewritten using the commutative property, because remember, this is just multiplication in between there. So that is why we know the commutative property says that we could switch the order of multiplication and it's still the same. So therefore, they are like terms. We would be able to add negative 3xy with negative 5xy because they have the same variable parts here. Okay, so if we look here, they have to have the same variables. So they both have x, but they also have to have the same exponent. So the exponent here is a 2 and this one's a 1. So automatically we know they are unlike terms. They both have y's, but the y has an exponent of a 2 and this one is a 1. So therefore they are not like terms. Okay, so here I see an x, and here I see there's an x here and an x here. So this is just not completely simplified. We could take this and rewrite it better as negative 3.4, since there's two x's being multiplied here, because this all means multiplication when everything is written together like that. So we could rewrite it like that. So now they both have x's in their term, and the exponent match up, so they have to have the same variable, which they do, and the exponent. So far so good. And then we have a y here and a y here, and the exponent for the y's are the same. They're both 1s. So these are like terms.